start the recording for those people who couldn't make it today. And I hope the session will be useful for them when they watch it later on and use it within their projects. Yeah, I believe my screen is shared. Let me just confirm that this is the screen that I'm sharing. Okay, cool. Today's topic is to go through some information about HERE Technologies and how and what sort of services we offer and how you can use these location services within your platforms or applications. So the topic is harnessing the power of HERE location services in your app. I'm going to be your host. My name is Sam Amir Ibrahimi, and I'm the Developer and Community Relations Lead for HERE Technologies in Oceania. Here's my contact details if you want to get in touch with me again. My contact details and my expertise are also highlighted on the website of the Open Innovation Challenge of the City of Melbourne. So you can also find me there and see what other sort of offerings I can provide to you and your projects. Let's move forward. Before I get into the technical side of things and explain to you what sort of offerings that we have, I want to give you a bit of a background about who HERE Technologies is, because that's one of the most common questions that I receive from people. So we basically go back to almost 4 decades ago. People used to know us in the 80s and 90s as Navigation Technologies, or Navtech in short. Nokia, and since early 2000 we continued as Nokia until they sold their business to Microsoft. Like specifically, they sold their mobile phone business, and the location services side of it was sold to a consortium of giant automotive industries. So I guess many of the people in the webinar, the users of HERE Technologies without even knowing it, whether you're receiving a parcel from post office, from the post services, or you ordered something, or that is being shipped to you via postage, or like delivery services, or you ordered some food. We're behind the scenes of those services. If you have a Mercedes-Benz, Audi, BMW, and you have a navigation system in your car, we're behind the scene as well. Our vision is basically to enable an autonomous world, and that is driven by good quality decision-making data that is aggregated and augmented by sensors from a variety of disconnected sources. And we're trying to implement a digital version of the reality into computers, and allow people to use this data and navigate within this environment for their businesses and personal use. So we've always been the best breed when it comes to the quality of the data sets, and we pride ourselves to have the best quality data in the world. And like various reports around the globe have confirmed that HERE Technologies quality is superior to other to its competitors. And this is not something that we just say ourselves, and we're proud of that. And we've been extending that through a connected platform that leverages the robustness of the data and exposes that data to even greater sets of users in a consistent way around the world. So our data is not great in one part of the world and really, really weak in another. So we maintain consistency around the world, and we basically maintain that standard of the quality all around the world. So now we're, as I mentioned, privately owned by a consortium of big automotive brands like Mercedes, Audi, BMW, Intel, Continental, Bosch, and as of this year, Mitsubishi and NTT Data have joined the consortium as well. In that sense, they're going to help us to develop our focus further, both into the autonomous world and also the IoT space. So just to give you an idea about like where we are at the moment and give you some stats. We have grown and evolved to 200 countries now, and we've mapped those 200 countries. Today, we've got more than 9,000 employees across 200 offices in 56 countries. Now, our maps are on board of over 100 million cars, and 4 out of 5 cars in North America and Europe and in other parts of the world are using our map data in their in-car navigation systems. There are more than 500,000 cars feeding all kinds of information to us. For example, this information shows when and where a car has activated its hazard lights, the driver has braked hard, or the windshield wiper was used, and many more. We're processing this information and then delivering warnings of upcoming hazards out of vehicles on the roads to the other drivers that are not aware of these hazards. So our fleets of cars, we have about 400 what we call them true cars. They're LiDAR enabled and they're constantly driving around the world and collecting data for our maps. The incoming data is basically ginormous. We have around 700,000 3D data points that we're collecting per second per car, meaning basically that we collect 28 terabytes of location information on a daily basis. We constantly update our maps with data coming from these and also other sources. And we have basically millions of changes made to our map on a daily basis. And as you can imagine, these numbers are not just stagnant, and they're increasing constantly. Just to give you an idea about our partner ecosystem, we constantly and continuously work with big names like the ones that you see on the screen, like Accenture, AWS, Esri, Nokia, NTT Data, Bosch, Audi, Cisco, just name it. And we provide them the data, and also using their IoT, we receive sort of probe information and that we can use to enrich our data. So just as a summary of what I'm going to introduce you to today, this is a portfolio of the HERE APIs that we offer. It's not limited to these, but this is just something that I wanted to show you, and I'm going to take you through them. And at the end of the session, we're going to have a bunch of demos that you can see, for example, how you can add an interactive map onto your web application, or use our REST APIs to, for example, to perform a geocoding or reverse geocoding action, enable the traffic or get the incident data from the roads. And also, like, we're going to do some exercises around routing and navigation and those sorts of things. So I'm really excited to be here with you, and I hope you're pumped as well, like to get some hands-on experience on these services. So with the maps, I hope I'm not too fast. I'm a bit conscious of time, and because I feel like I want to give you as much information as I can, so you can have a clear idea about our offerings and how you can use them within your projects. So the map APIs that we have interactive customizable maps. Whether you want to access them through a JavaScript API or a REST API, you'll be able to do that. And also these are available on our mobile SDKs for both iOS and Android. Yes, you can receive map images, and you can do the navigation at the same time as well. And you put that line from point A to B on that map image and show it to your clients. So you can you can also customize the map. You can define your own styles and colors, and without people knowing that's a HERE map in the background, you will be able to showcase your applications. So that's a added benefit of using HERE maps. We have indoor venue maps and also geovisualization services, which I will get to soon. And yeah, there are other services that you can receive sort of feedback on the maps that you have, or add custom map objects. As I will show you in the demo soon, this is an example of using a accompanying YAML file to your map that includes all the defined the styles, for example, the fonts for the labels, for the colors of the roads, the parks, water bodies, and so on and so forth. And you can use that in the runtime to load your map with the styles that you have in mind. This is an example of an embedded interactive venue map. For example, think of this is as an example, let's say Melbourne Central, and you can include the indoor map of the Melbourne Central here, and you can change the floors and see all these businesses. So in that sense, you can use this information in your application, for example, for delivery purposes, or disaster management, or emergencies, and whole heaps of other applications. In terms of geocoding, I probably don't need to explain to you guys, you're all tech savvy. So geocoding, in the sense of location information, means you give the service an address and it will return the coordinates for you. As the name suggests, the reverse geocoding will receive a coordinate and it will give you some suggestions about the potential addresses that are in that location with certain proximity to that point that you mentioned. We have geocoding autocomplete. As you type, the system will and the service will suggest information to you. And we have places like points of interest. Let's say you want to go to a Starbucks or Brunetti or the State Library. You can search for it and it will give you the location as well. So I'm just going to show you some screenshots of Geocoder here. This is an example we developed in Australia. This is our office in Richmond. Basically, we entered the address and it dropped the points over there. And we also, for less developed countries, and also for applications that need more flexibility in terms of addressing, we support what 3 words system as well. So what 3 words are, the world has been gridded into 3 by 3 meter cells, and each of those cells are named with 3 words. So you have a unique sort of informal addressing system to access different parts of the world. And yeah, we support that too. So in terms of routing and navigation, we have world-class navigation services for cars, pedestrians, trucks, and also we have intermodal routing. For example, from point A to B, give me whatever means that I can use to get from this point to the other. And we have all the public transport's transit timetables, and in that sense, we can use these sorts of information to give you all the routes that are possible between 2 points. We have live traffic, and you can enable it in your routing, and I will show it to you soon. And we have truck-specific routing as well, as you can imagine. And probably it's going to be relevant for the purpose of this session and the Open Innovation Challenge themed waste and circular economy. You might want to be using truck routing to deliver the waste or wherever it needs to go. And the difference between the normal normal car and the truck is that trucks are bigger, they're just sitting higher on the roads. And it's not probably rare that you can hear the trucks hit underneath of a bridge, and the whole road section is closed. So we allow for the user to include a lot of the truck specific information, like width and height and weight limitation and all those things for efficient routing. And yeah, the next one, and one of my favorite, is the isoline routing. So for a given point on the map, and certain criteria, for example, a kilometer distance or 5 minutes of driving, how far I can travel along the route, the road network. And in that sense, you can use this for ride-sharing application, for example, saying in 5 minutes time, how far I can be, will I be able to meet you in that location or not? So these are some of the use cases and questions that you can address and answer. And the last one, but not least, is the matrix routing. So for a given number of points on a map, it will calculate the fastest route between them, and it will give you the distance and also the time that it takes for you to go from point A to B, and A to C, and A to D, and B to C, and B to D, and so on and so forth. So this is a screenshot of advanced truck routing. You can see you can define the regions, the starting and destination points. This is an example taken from Frankfurt. You can indicate what sort of hazardous materials are on board, and also like giving additional options like to include or avoid toll roads and motorways, or rails and ferries and all those things for the truck routing. And then you can click on calculate, and it will give you the most optimum route that the truck can use, and of that specification can use to take that load from point A to B. As you can see, we also provide live traffic and historical traffic and road incidents as well. So in that sense, you can use this information to optimize your applications. You can just include the live traffic and incident reporting information into your routing calculation just by enabling it. So you can say traffic enabled, and that's all it takes for you to have a traffic enabled routing in your applications. This is an example of the matrix routing, as I mentioned. So for 8 points that are on the map, you can see the distances and also the time of travel between each and every one of them. This is a snapshot of isochrones created by the HERE API. So our HERE office in Melbourne, we calculated 5 minutes, 7 minutes, and 10 minutes of driving, and that's how far you can go. And at the same time, once you know that, you can extract the road network from there, and you can work on that specific road network to optimize your application rather than just including everything and everywhere. So that you will have that added benefit to it. We have other services, we call them fleet telematics. You can add custom locations, geofencing, which is another one of my favorite services that you can use, and you can create polygons and areas in different parts of the city, or near your home, or anywhere that you want to add them. And once the location of something that you're tracking gets within that polygon, it will fire up a notification or fires up a service that you've mentioned, and it will do something. It can notify you if someone's entering your backyard, or if your truck that is delivering food, it reaches the proximity of one of their destinations. So you can call them. It's like, hey, yeah, it's going to be there in a couple of minutes. We have advanced data sets. For example, we have road speed data, we have road slope, surface roughness, are just like a few examples, and you will be able to access that through our APIs as well. Another service that we offer is called Waypoint Sequence. If you're familiar with the good old traveling salesman's problem, for a given number of points, you want to optimize how your truck, or you want to your vehicle or yourself can go through all of these points in a very optimum way, and it will give you the order and also the travel time and all the other indications as well. So I'll give you a demo of this to you shortly. We have toll costs that will be included in the routing. I'll give you an example soon. Route matching and custom routes, and also that some services that will enable fleet connectivity using IoT devices as well. So this is an example of geofencing. I created a bunch of polygons here, as you can see. And if this truck that is traveling to here, if it reaches this polygon right over here, it will fire up a notification here and then we can grab it and do something with it. This is an example of this speed limits and the street sign that you can access through our APIs. And the road slopes. For each road segment, you can calculate the value of the slope. As you can see, it can be used in applications for safety, and at the same time, if you're driving an EV car, you can this will affect your fuel consumption and basically electricity consumption. And you want to know like how far you will be able to go if it's a mountainous area, or it's a flat, more like a flat area. I explained this. This is a traveling salesman's problem. From these points, that's the best route that you can go for. And for example, another scenario will be like one of these roads are blocked, and so the order probably will change to from 1 to 3 to 4 and then to 2, or vice versa. It depends on like their road network in that area. So the algorithm in that API will calculate it for you, so you don't have to worry about anything to do it yourself. Another example is routing with the toll costs. It calculates the routing and also give you the cost if you're passing through the tolls. As I mentioned before, in the routing algorithm, you can specify to avoid certain areas, countries, or roads that are, for example, like toll roads. These are the matching GPS trace APIs and the maximum road speed API. So as you know, the GPS depends on the location, and the area that you're in may have different level of accuracy. And so this is an example that like as the car is traveling through this road, the GPS signal bounces off like here, 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 here. In this case, like it's very far off. So using this, you can pass on all these coordinates, and it will calculate the trajectory, and it includes many other parameters to tell you that with most probability, this is the road that you're traveling in. And in the sense of the safety sort of aspects, like there is a maximum speed road, a road speed that you can see, like if it's 100 kilometers an hour speed limit here, but as you can see, probably the safest wouldn't be anything more than like like 90 or 80 something, because of the road's nature. And we also offer a bunch of other APIs for registering your devices as IoT, positioning, shadowing and tracing and geofencing sort of APIs to use with IT devices. These are some of the applications that we have developed. Here locate and here track it, that you can go and register your mobile device and transform it into an IoT device, and you can track them, and you can get different reports around it as well. And this is an IoT device like that we use, developed by one of our partners to be able to simplify and make life easier for different applications that they don't vendors that they don't have like a embedded IoT device in their solutions yet. And surprisingly, we have also weather APIs, and it's not just an API to tell you um, like whether it's sunny or rainy. We have like tens of different sort of parameters that will give you like what the exact situation is, and you can use it within your apps. This is a web-based visualization platform. It's a three-dimensional visualization platform that you can use to visualize your information and data. It's called HarpGL. It's open sourced, and as you can see, like it's the content of this platform is similar. It's the same data behind the here maps, and but we like very much enhanced visualization functionalities. As you can see, this is the map of the Melbourne. You can completely change the visualization and make it very impressive. So this visualization specifically focuses on buildings, but if it's something that you want to visualize on the road and there are different parameters you want to highlight on the road, you can switch to that and create a very impressive visualization for your audience. All in all, want to say like we have a lot of useful APIs and SDKs that you can use, and up to 250,000 transactions a month. They're free of charge, and you can imagine how much added benefits it might have for a small business, a student, or university education systems. And also like startups, we have created this freemium offering to support all these people who don't have access to expensive plans, and we're going to enable them with 250,000 transactions a month, and at the end of the month they get a reset, and you will have a fresh 250,000 transactions for the next month. Before I go to the demos, I just want to show you our here developer portal. This is the web address. I highly recommend that you go and create an account. You can see the products and the documentations and like the other offerings that we have, but I didn't get a chance to explain to you and introduce to you today. So the address is here.is/devs. This is the shortcut web URL, and it will take you directly to the developer portal for Here Technologies. So again, here.is/devs. Go there and explore our services. So with that introductions, I want to start with our demos, and let me just tell you what I'm going to do next. So I'm going to start with the interactive maps. I want to tell you how you can quickly, in less than 2 or 3 minutes, to create a web map and customize the style and coloring in your application. So this is my Visual Studio Code. I don't know if you're familiar with it, but if you don't know how to work with it, I'll try to explain as I'm going. So I'm just gonna create a project. Let's say project 1. And I'm going to create a simple HTML file called index.html. It's going to give me an empty file. Since I have been prepared, I will drop in a very simple sort of HTML structure here with all the stuff that we need. So everything's pretty much standard up until here. You need 4 scripts that we need to call from the internet. The first one is the map JavaScript core script. The other one is map.js services. Third one is the user interface components that you can have, and also the map events. So these are the only things that you need to have your map. In addition, I just want to include one more thing in the body. that is basically a paragraph that says this is an example of a here interactive map using JavaScript, and a div with the ID map, which will be a container for our map with the style 500 by 500 dimensions. Yeah, we're all set. Let me just run this for you to see. Yeah, so you can see the paragraph, but you can't see the map because we haven't done actually anything regarding the map. What I'm going to do right now, I'll add an embedded script with type as a text JavaScript. I hope it's not too boring for you. The first thing I need to do is to create the here platform sort of variable, and I'm gonna use a new hservice.platform. I need to pass on my API key, which you can receive by registering for an account on our here developer portal, and that's all it takes. Now you have the here platform. The next thing you need is to define basically the layers that I want to use for my map, and as simple as create default layers. I'm going to use the default layers. Now I'm going to create the map. So I'm going to get that document get element by ID, the map element that I created earlier. So that's the first parameter. I'm going to pass on the default layers, and I want to have it as a vector map, and a bunch of parameters to tell them where we need to look. Instead of typing it, I'm just going to copy paste it from my example. So it's going to look at the center of the Melbourne CBD, and the zoom level will be 10, and the pixel the pixel ratio to the screen will be 1. What is happening here? Just going to save this. Okay, apparently I closed that one. Yeah, now I should be able to open this and see the map, but I can't see it. Let me just quickly check. Okay. Because my API key needs to be like that. Default layers, transform, create default layers. Yep, I was typing too fast. So yeah, we should be able to see a map that is centered on Melbourne. Let's make it more exciting. Let's, as you can see, it's not interactive. I'm clicking on it, it's not doing anything. I'm just gonna go and add a behavior to allow for zooming and panning. New H map events. Dot map events. Yeah, now we should be able to move around, and that became an interactive map. that simple. In less than 5 minutes, you were able to do that. Now, the other thing that I want to do is like to add, let's say, traffic and incidents as well. So I'll do var, sorry, map.add a layer. I've defined the default layers, vector, normal, and let's add traffic. And I'm gonna copy and paste this and call it traffic incidents. When I load the screen, I'm sorry, I think I was sharing the wrong screen. Yeah, now you are able to see the traffic information and the incidents as well. Okay, we have a question. Can't see, just showing demo page. I'm really sorry, Len. Can you? I hope you can see it now because I shared my other screen now. Yeah, so that was the code. This is defining the platform, the default layers. This was the map, and the behavior, and adding traffic and incident data. Yeah, the next thing I want to show is how you can customize your visualization. So the first thing I want to do is to add a map provider sort of variable, call it a provider, map get base layer get provider. The next thing will be to define the style of the map, another variable, I will call it style. And let me just use one of the things that we've created before. It's a YAML file, and if I show it to you, it will look like this. This is from the GitHub repository of here maps. And for example, you have RGB values here. So, and these are the places and the outlines for class 2 place, whatever it is. So if you change the values, you will see different colors for that particular feature on the map. So I'll go back and use that as the address for the style that I want to use, and we are going to use a constant base URL that is this, and that would be it. All you need to do now is to call the provider and set the style to style that we defined earlier. Now I'm going to save it, reload the map, and you should be able to see it. Well, you should be able to. There was an error over there. Yeah, this map style was completely changed based on the style that we defined for it, and it's called the dark.white YAML. So that it was as easy as that. So the next demo that I want to show you is how you can use geocoding APIs. If you're not familiar with Postman, it's an application that you can use to run REST APIs or other type of APIs. So for the geocoding, I want to basically show it to you here. So the base URL is that. I want to use the geocoding API to showcase one of my friends' houses in Brunswick East. So the to get the coordinate for that address, that's the base URL, the geocoder that is the hereapi.com. That's the version 6.2, and that's the output that I want to ask for. So the search text is the address, 87 Barclay Street in Brunswick East, and that's the API key that I have acquired from my here developer. Let me just go to the header that is /devs. If you click on sign up, you can create an account. I already have an account. I'm going to log in, and I'll show you where you can acquire these credentials for your APIs. For the JavaScript, you would need that as well. Right. So when you create an account, you will be given something called My Project. Yeah. And you can create an API key for your JavaScript. I've already done that, and I've used it in my previous example. For the REST API, I also have created one, and I can copy it and go there and paste it instead of that example. And now I'm ready to go to get the coordinates for that address using one click of a button. And there you go. So it's a point address, and the display location will be, or not even navigation position will be the same. So that's the coordinate for that address. As easy as that. Let me show you how we can do reverse geocoding. Similar type of example. Now I'm using Places API, and it's an auto suggest around a point here, and I'm looking for all the Commonwealth banks in that area, and I'm using my API key that I mentioned earlier. So once I click send and send that API request, it shows me the locations of all the Commonwealth banks in that area. So that's the title and the information about what I've requested. So the first Commonwealth bank will be this one in the results section, the position, the category, the title, and all sorts of other information that you can get about that point of interest. And around Melbourne, you can find all these different Commonwealth Bank branches and ATMs as well. All right. So for this particular one, we were just looking for the banks, but you can specify, this is another example, you can specify like what sort of target you're looking for. And it's a reverse geocoding around proximity of this location. And the mode will be to retrieve landmarks. And when I press that button, and it tells me around that location, it's the Queen Victoria Market. And the location type is a shopping center, and that's the address and all sorts of other information about that. And yeah, and there are other things around as well that you can see. For example, Lincoln Square is also in that proximity of that within 1 kilometer radius. What else? Let me see if I have other examples for you. This is the geocoder. Don't worry if you're not familiar with how to construct these REST APIs. On our developer portal, here.is/devs, you can find the information about how to construct these and how to use these, and what other parameters that you can include to refine your queries. So this is another example that I'm looking for retrieving an address, and that's the location that I'm looking at, like to understand like what sort of address it is. So I used the output of the geocoding that I got, and it returned to me my friend's address here. Yeah, pretty quick and simple. You will also be able to do batch geocoding. If you have millions of addresses, you can use only one API call to batch geocode them all in one go. And once the result is ready, you can download the result within your application or locally and work with the outputs. Yep, let me clear everything. The next thing I want to show you is the Here Routing API. It's going to be a simple routing with a car using a fastest route, and I'm going to enable the traffic for you to see that. So the base URL will be the router hereapi.com version 8, and the rest is the query. So my transport mode will be car, the origin will be this location, and the destination will be this coordinates. So what I'm going to ask in return is to give me the polyline of the route, and also give me the travel summary, the actions and instructions. So the actions are the actions that the driver needs to take, and these are some human readable instructions for the person to understand it. I also want the elevation of the route as well, like how high and how low it's gonna go. Also, there will be some spans which will indicate the name of the sections and also the speed limit. I wanted to see like the speed limits in those sections. And if I want to specify any alternative routes, I can specify their numbers. But at this point, I just said, don't just show me one route and zero alternatives. The rest is straightforward. Yeah, pass on the API key that you have for the rest and press send. Yep, the results are calculated. So here's the route that we got. The ID is that, the type is a vehicle, and actions. For example, it will tell you the action is to depart. Instruction is head towards South Bank Boulevard on Stewart Street and go for 97 meters. And that's the first section. And the next instruction will be to turn left onto South Bank Boulevard and go for 239 meters. All in all, for that route, it gives you the instructions. It will give you the departure and arrival coordinates, and you will get the polyline in an encrypted way. And if you go to our here developer portal, there will be instructions how to decode them using a provided library. And these are all the spans. For example, on the span will be the Stewart Street, and the speed limit for that is 60 kilometers an hour. The next one, as the instruction mentioned, you've got to continue on South Bank Boulevard, but the speed limit will be 40, and so on and so forth. You can use information like these to construct your instructions and also visualize the route on your application. So think about this as an example of a truck driver who's delivering waste, that how easily they can use on this information to optimize their routing and deliver it in a more efficient way. So in this one, we did not include the traffic. However, the version 8 probably doesn't support traffic now. You got to revert back to version 7, and route is hereapi.com version 7.2, and calculate the route, and I want the output in JSON. So the first waypoint will be the origin, and the next one will be the destination. The mode of the travel will be fastest using a car, and the traffic equals enabled. And that's the difference between what we had and what we have now. So when you specify the traffic, you have to mention the departure time as well. You want to go now, or you want to go in an hour, or you're going to go in a few hours. And based on that, if we have the live information and you're leaving now, not to if like once we have the information, if you're leaving now, we're going to give you the route instantly. But if you are leaving in a few hours, we have historical data that we've compiled and analyzed, and we have created the predictive model to predict the traffic in the next few hours, and you can use that. And the rest is to pass on the API key, and I'm going to send a request. And this is the results that you get from the API. So that's the inputs, and these are the legs of the trip. You've got to go there, and then you're going to go there, and the length will be that. And you have maneuvers and human readable instructions for each of these maneuvers and sections as well. I'm not going to get into the details of these things. You can explore them and read more about them on the developer portal. I just want to give you examples to give you an idea what sort of things that you can use from HERE Technologies for building a useful application and win the challenge in this competition. So you remember I mentioned about the traveling salesman, the waypoint sequence. This is going to give you an example. So find sequence, the base URL will be the same, but the version is the version 2, and find sequence. So I've mentioned that the starting point would be Great Northern Hotel in North Carlton. That's the coordinate. And from there, I have a few options that I can go to the bistro to deliver some groceries and food, and it's there. DLC Pizza on Lygon Street will be here, and the Sovereign in this location. And I want to end up going back to Richmond Station and get more groceries from there in that location. So the mode will be the car, and the commute will be the mode will be fastest. I want to go from point A to B in the fastest way, and I want to depart now with traffic has been enabled. If I press send now and call that API, it would order these destinations from Great North Hotel to Richmond Station, and it will give me so I have to go to the Sovereign first, and then DLC Pizza, and then Bistro, and then end up in the Richmond Station. And I have asked for information like distance, time, and I could add waiting time between them as well. And it will give me the overall number of seconds that I need to drive between them. And yeah, so and for now, because I don't have any waiting time, and considering the traffic, 2,528 seconds it will take me to drive between all these. I think we get to the second last example for today, the isocones that I mentioned to you earlier. So from any given point, how far I can travel to through the road network to be in a particular place or meet the person. So the base URL will be isoline route is HERE API routing version 7.2, and I want to calculate an isoline. Again, the mode of the travel needs to be specified. I chose the shortest path. Using a car, I have disabled the traffic from this particular location in Melbourne. And I want to know how far I can go on the road network if I travel 1 kilometer. 1 kilometer, how do I know that? Because in the range type, I've specified distance. I could change it to time and it will be in seconds. So I don't want to do that. Oops, I deleted everything. And basically I want to know if I drive for 1 kilometer, how far I can go on the road network. And I press send, and basically it will calculate for me a polygon that its shape is defined here. It's explained in plain text. And yeah, you can grab it and process it and visualize it on a map the way that I showed you before. And it's easy as that. The last example for today will be matrix routing. And I like this API very much because it will tell you from any given number of points to any other points how long it will take and how far the distance between them are. So the base URL is this, and I'm asking it to calculate the matrix. And these are the points that I've specified. So this. So overall, I will have 1, 2, 3, 4, and 5 points. The mode again will be the fastest using a car, and in this particular case, I have enabled traffic. And in the summary attributes that I want to see is travel time between any two given points and the distance between them. When I pass on my API key here and click and send a request, you can send requests using applications or other platform, no worries. And yeah, this is the matrix that I get. So from point 0 to destination point 0 is this. That's the distance, travel time, and the cost factor. To point 1 is this much. To point 2, the distance, travel time will be this, and to the last point will be like this. Okay, I think that's enough for now. I think you have a lot of information to digest. As I mentioned, I'm recording this session and I will sharing it with everybody who are here today, but need to revisit some of this information, and also for those people who couldn't make it today, they can refer to this and learn about our offerings. Yeah, let me just go back to the slides. Yeah, so those were the demos. And again, I want to point you towards the direction of our HERE developer portal, where you can see all the information about products and the APIs and SDKs, all the documentations, the blog posts, which will include a lot of tutorials and examples, and all the documentations around the parameters for APIs and how to use them. All the guides and everything is up there. So go to here.is/devs, create an account, and start exploring. Yeah, that was pretty much the webinar today. I went 5 minutes over time. I apologize for that. I hope this session was useful for you. And if you have any questions or you needed mentoring, please reach me out at sam.amirubrahimi@here.com. My informations are already on the Open Innovation Challenges website in the mentoring sections. And if you have any other questions regarding the hackathon, the challenge itself, you can use that website and communicate with the organizers. Do you have any questions before we wrap up? Len, did you say anything?
No, Sam, just thanks. That was great.
Thank you very much, Len. And thank you and everyone else who stayed with us until the last minute. I appreciate that. Okay, I'll wrap up this session, and please feel free to reach out to me if you needed me. Thank you, and see you later.
Thank you.